Okay guys, so I'm going to summarize here the most important aspects of operating systems from the basic point of view and also to get into the specific features that they have and the most important functions they cover and also some of the utilities that you have in the operating systems nowadays. So an operating system is just a layer of software that is working on top of the hardware. So if we think of a computing system as a stack, then we could say that we have on the bottom of the stack we have the hardware, and this hardware is controlled by basically it's kind of between software and hardware, which is called the firmware, and on top of that we have this layer of software that is called the operating system. And what this software layer does is to provide both access to upper layers of software, and it also controls and operates the hardware, right? So obviously we're using making use of the firmware, because firmware is just circuits or microprocessors that have instructions there of how each one of the devices of the hardware should operate. But in order to control that from the software side of view, then you need the operating system to be that sort of like an interface, right? It's an interface between both upper layers of software and finally the user. So on top of the operating system, we have what we call applications, and there are different sorts. And then we have what we call the interface for the user, right? This is where the user is. The user uses applications that are making use of the operating system, which controls and manipulates and manages the hardware. That's just the most basic structure of the stack that I can think of, because we could say that, for example, the operating system, it's divided into main parts, in two main sections. The OS, as most people call it, it has two parts. One of the most important part is called the kernel, and the kernel is I could say like the part of the operating system that handles the most important tasks, and the tasks that would, without these tasks you could not use the computer system. And there are some other things that you have there, like maybe utilities in the operating system, and some applications even, and yeah, I would say that's it. So you have either utilities or apps in the kernel. So the kernel is, as I said, the part of the operating system that handles the most important tasks in the computer. So let me just grab a picture here so we can see what I mean by the different functions and what are the most important ones. So this is an example of what the operating system does. So I would say that the kernel would have um, mostly, we could classify the functions as most of all process management, and that is handling how programs have access to the CPU. And this is why you have the ability to run multiple programs at the same time, because the programs, if you, let's say that you, let's think of programs of like lines of processes, right? So let's say that these are the three processes that we want the program to run. Let's say that the blue is user interface. Sorry. Let me just erase that. User interface. Let's say that the green is, let's call it, I don't know, printing service. And that the yellow one is WeChat, right? These are three different processes, and each one of those lines is made out of a lot of instructions, right? They each one have code that is to be executed in the computer. So what the computer does is, I think I explained this in a different video, is it starts jumping from one process to the other. So it starts here and it executes these two instructions, and then it jumps here and then it jumps here, right? And this is what it's doing all the time, but it's jumping so fast that it looks like the three lines are being executed. And this is called process management in the kernel of the operating system. So one of the tasks that the kernel is doing is process management. The other one is obviously memory management. And this is handling how programs are being loaded to the main memory, and how, for example, when the memory is full, then we need to take parts of the program to what it's called virtual memory. So which is part of the secondary storage that stores programs that are being run. So that's also part of the operating system functions. So we have these two, and these two are part of the kernel, right? We have, I just mentioned multiprogramming, right? So that means that we have even we have different threads in the same program. So maybe the printing program has two lines instead of one. This is, for example, well, maybe not, the printing program is not a good example. Maybe the WeChat is better. So we have some downloading files while I'm talking to someone, right? So it's doing like kind of two tasks at the same time. That could be done if we have multiple cores in our processor. So the operating system is able to say which of, well, I mean, to what core of the processor is sent each one of those tasks. That's multiprogramming, and multitasking is what I just explained, that we can handle multiple tasks at the same time, right? Another one that is usually assigned to the kernel is the input and output control. So if we are going to handle, for example, drivers for USB devices, or drivers for Thunderbolt devices, like, I don't know if you are familiar with this, but this is the new port that we have been using the latest years. And keyboard, to handle the user input. So any other input and output devices that you can think of are being handled by this, even the screen, right? So that's also part of the kernel. And the access to the file system. I don't know if this is not in the picture. Oh yeah, file utilities. So this is to solve all the creating files and folders and accessing them and organizing them, and the hierarchy and all that is part of what the operating system does. And it's part of what the kernel does, actually. So if we summarize this tree, we could say that what the kernel is doing is doing all the resources management, right? Because in the end, that's what all these guys are, right? Process is the CPU is a resource, memory is a resource, input and output devices are resources, and the file system is also a resource. So that's one big part of what it is. Now, some people could say that that depending on the operating system, that the user interface is part of the kernel. That is true for operating systems like Windows, like Mac, right? So the user interface, for example, in Mac, you have also a Windows system, which is part of the OS X, and you have things like Finder, for example, and in Windows you have the Explorer and all that, and all the windows that you have in both systems, these are part of the kernel. But if we talk about operating systems like maybe Unix or like Linux, these operating systems, they have a way to, they have a Windows system, but you can install on top of that user interface, like I don't know, the terminals. You can choose the terminal that you want, or you can even choose your desktop application. So, and your desktop graphic user interface. So for some of them, these are kind of like apps or utilities that you install on top of the kernel. So user interface could be part of the kernel or not, depending on the operating system. So this human interface could be part or not part of the kernel. Batch processing, that should be part of the kernel, which is when you want the computer to run tasks at certain time, like I don't know, like for example, I want to create a backup to the cloud every day at 12 p.m. That's going to be something called batch processing, so that'd be part of the kernel. Error handling, it's completely part of the kernel, and that's part of the, when we have errors in the programs that we're running, the operating system should be able to handle those errors and to know what to do. For example, if there's a problem with the mouse, right, or the screen or the printer, then this part of the kernel is going to solve those problems. Loading and running applications of software. So for example, when you double click on WeChat, it's actually the operating system who's providing the resources to WeChat, so you can see it on the screen and to have access to the network and all that. So the operating system is providing some services to these applications, and the services are things like networking and file access, and even device access, like when, for example, when it's the camera, you need to access the camera, is the operating system that that allows these applications. So for example, we have WeChat here. WeChat is going to ask the operating system for permissions to access networking, file access, and camera, and all that. So that's what you would say that is providing programs with access to other parts of the computing system. And also it allows the programs to run. So when you double click the WeChat icon, then it's the widget asking for permissions to the kernel to be executed. And it's actually the operating system that, after you double click it, that takes all the instructions that you have in widget as part of the program, and it loads that into memory. So it brings it from the secondary storage to the primary storage. Like from the hard disk to your RAM. That's what the operating system does. It takes it from your hard disk to your RAM, and it gives this process, all the bunch of instructions. It gives this program access to the CPU. So which becomes this line, right? So it's basically giving you access to everything in the computer. For example, security management. So if the user has permission to open WeChat or not, or if the user has permission to create more users in the system, what's the password for each user and all that. That's all handled by the operating system. One important part is the interrupt handling routine. So that's when when I'm jumping from task to task, right? I need to stop the process. So when I was in the UI, I stop this process, and then I go to print and I stop this process. So I need to stop and then move to another task, right? That the process of stopping one process is called an interrupt. Well, an interrupt causes the stop of the process. That's actually what it is. So interrupts are a mechanism in the computer that allows the all the computing system to stop doing one thing and moving to the next. And for example, there are other types of interrupts, like for example, if I want to I'm working in a WeChat, and then I say I want to open a picture that I have in the computer. So that part, it's going to ask for the operating system to go and find in the file system the file and then bring it to memory. That it's going to take a long time in terms of CPU process, because loading things from memory or from the hard disk is a very it's a time-consuming task. I know it doesn't look for you, but for the processor, that's if it had to wait for things to load into memory, it would be a very slow computer, because the CPU does billions of things per second, and the tasks of bringing things from the secondary to the primary might take milliseconds or even seconds. So that's too much to wait for the CPU. So the interrupts serve as a mechanism to notify the CPU that, for example, the file has already been loaded, or maybe I need to stop the UI to ask the printing to send things to the printer. So all that is being handled by the interrupt. So the interrupt handling routine is just a bunch of steps that the program has already stored, the CPU has already available, like in firmware, to stop doing things and then move to another part of the memory, or to another part of another process that is loaded in memory. So that means like for running from UI and stopping the UI and then go to print, and that's what I mean. Okay, so yeah, those are the most important ones. And regarding the user interface, I should mention that there are two main types of user interface. We have the command user interface, or the command line interface. Yeah, it's better that term. Just forget about this one. Command line interface, CLI. And we have also the ones that you use. I think many of you have never seen this, but at some point in the course we might see it. And the graphic user interface, which is the windows that we use all the time. That's very common, right? Um, I mean, in Windows and Mac, in your phones, because your phones are computers, um, you have a graphic user interface nowadays, right? But it wasn't like that a few years ago. And you have some command line interface uh, capabilities nowadays in the computers. In Mac, you call it the terminal. In Unix and Linux is the same, and in Windows is called CMD, the command interface. You might have seen it before, but that's just another way to start telling the computer what to do, right? Um, I think well, another important aspect it's that I just mentioned a little bit is the security. So it has to do with providing both access and users to access to the different resources in the computer, and making sure that each user has a password, for example. And that's just to prevent intrusion of unwanted users in the system, and also protecting the information that you have inside the computer, right? Um, Now, I mentioned that there are some utilities in the computer, right, that are not part of the kernel, but, well, maybe they are depending on the distribution of software that you have, but it's usually not part of the kernel. It's part of the applications that you have that you can add to your operating system. One of these tools is the hard disk defragmenter, uh, and is just trying to handle. I mean, when you access the computer and you start saving files, this, let's say that this is the memory in the hard disk. When you put a file there, then you start filling spaces of memory, right? And if things were handled properly, then you would have a very good use of the space in memory, right? Like you would be trying to accommodate all the programs in one side of the memory. But when you delete or do one program or a file, for example, let's say that I'm going to take this green program or file out of the memory. Then you start seeing that there is a hole now, right? Here, and if I add another one, then I have this problem that you start having like empty spaces of memory that is being unused, and maybe it's too little to put other programs, right? So that's what we call fragmentation of the hard disk. So one tool that you could have as part of the operating system, as part of the utilities of the operating system, is a tool that would rearrange all these things and it would put them in the right place, right? So we would, I don't know, take this program from here and just put it there. Oh, right? And accommodate and this taken here. So, you know, it's all packed in one place so you can read faster your hard disk, right? So that's what you call the defragmentation utility. There are others like obviously backup software, right? If you want to back up and to put your information somewhere like in the cloud, right? Or maybe you just want to take that into a hard disk, an external hard disk, and make a backup of your files, of your pictures and movies and all the things that you want to keep, or your files from the school. Then you want to make a backup of that information. So there are some operating systems that bring that utility there. Another one is, for example, file compression. File compression is a utility that allows you to take one file that, for example, is, I don't know, let's say that you have a picture that is very big, or you have a bunch of pictures, and each one of those is 10 megabytes, right? And you have, I don't know, 1,000 of those. So maybe you want to pack this and compress them so it is not 10 gigabytes of size, but it's more like 5 gigabytes of size. That's the process of compressing. You're going to see in in the coming years of CS that there are some techniques to compress this. You have lossless. Oh, maybe you have worked about this lossless and lossy compression, right? So that means that you can lose information or not. In case of file compression, you shouldn't lose any information, so it should be lossless compression. And that's something that you could have as part of the operating system, just a tool to take files and make them smaller, to keep them, not to execute them, but just to travel. I mean, to move them around and to send them and all that. I think you already have done that. I mean, I think you have been able to compress files in your life, so you should know what I'm talking about. And maybe in the sense of security, we have from the utilities also virus checker and antivirus, right? Maybe that's part of the operating system. Nowadays, it's kind of mandatory to have that. Right. Another part that is important for us advanced, let's say, users of the computing systems is that we should have here as part of the kernel something called the API. And an API is, let me just bring that concept here. It's an application programming interface. So it's when I want to make programs that run in this particular operating system, the operating system has some libraries and an application programming interface, which is a bunch of libraries actually. And these libraries are just programs and programs and routines and instructions that we have packed that allows us to access things in the hardware or whatever we have of the resources that we have in the computer. So for example, if I am making, let's say that I'm talking about the iOS operating system, right? This is for phones from Mac. They have their API, and what I do when I'm trying to create an app for, I don't know, a WeChat app, right? I'm trying to create the new WeChat. Then instead of writing instructions for this particular machine, right? What I do is I write instructions in a programming language, and then I include these libraries and these API instructions that I have available, and then I would be able to handle, for example, the camera, right? The camera is one resource that the operating system is handling, so I need to ask permission for the iOS, right? And that's going to be through the API. So my app is going to talk to the API of iOS, so I can develop an app that handles camera. And that's the same case for any operating system. So when you're developing software for a particular operating system, then you need to know the API of the operating system, and you need to know the libraries that are available there, right? So these libraries, as I said, are just functions that you have there that are available for you to make use of the operating system. And as part of this application programming interface, you might even have other types of software that are, for example, compilers, right? For example, some distributions of Linux have the GC compiler, which is a compiler for C++ programs, right? So when I write a C++ program, I can use Linux to just try to compile the program and see if that program executes. And well, that's the process of software development. I'm gonna try and talk about it in the next slide. So you, for those who want to follow the system software part of the course. I think that's it about operating systems. I think I mentioned the most important features. So thanks all for watching, and Uh, this is just the first part of the introduction part of what it's called system software. In system software, we talk also about this specific parts. I mean, this specific type of programs that are the compilers and the interpreters. But that's just part of another video, right? So thank you very much. Take care. Bye bye.